Welcome to the Data Playbook podcast. In this podcast, we aim to build a playbook for data leaders to be more successful with data. We do that through a series of interviews with other data leaders, experts, and data practitioners. The topic of today will be SQLMesh, and I have with me Michiel. Michiel, welcome to the podcast.
Thank you.
Can you, before we dive into SQLMesh, first introduce yourself?
Sure. So my name is Michiel De Muynck. I have always been passionate about coding. This started from a very young age where I wanted to make video games, and I downloaded this program Game Maker where you could visually drag and drop. Essentially it's a sort of visual way to program, and then gradually that evolved into more and more actual programming when I ran into the limitations of the visual programming, and ultimately it ended up with me doing studies in computer science, and then even a PhD in computer science, and then started a postdoc in computer science. But after a while, I had a bit enough of academia, and I decided, okay, let's maybe look at what I can do as a real job, actually use the skills I have in the real world. And then I just looked at some companies, and I found Dataminded, which at the time had or I think it still does, has a data engineering manifesto on the website. And I was reading that, and I was really in agreement with that. And I was like, this is, I want to work at this company. And so that's how I started and joined Dataminded.
Wow. So are you saying academia is not a real job?
It's much more stressful now working for clients and with daily stand-ups where progress is really measured. You get a lot more freedom in academia. It's of course still hard work and still a real job, of course, but I also had more time to do to experiment with computer science, to really I had a lot more freedom then. But of course, yeah, it's at the end of the day, you still need to write your papers, you still need to write the dissertation, you still need to go to conferences, present. So it's still also a real job, but it's a very different world.
Yeah, you don't have to put things in production, right?
No, indeed. The code, the quality of the code does not need to be maintained for a long time, depending on the project, of course.
Right. So in this podcast, we're going to talk about a relatively new technology on the block called SQLMesh. But before we dive into what is SQLMesh, can you give a bit of the context SQLMesh fits in this philosophy of analytical engineering? Can you talk a bit about why we need something like SQLMesh? Where does it fit in the landscape?
Yeah. SQLMesh is a tool similar to, it's hard to talk about SQLMesh without mentioning its biggest rival, dbt, which is the king in this analytics landscape, or at least the SQL-based analytics landscape. And so these are both tools to ultimately work with SQL queries and SQL more as a computer science or a professional where you're using the principles of computer science instead of just working with queries directly. So as an example, basically if you're just an analyst where you manually enter queries in a warehouse to calculate reports, you will, if you start collaborating with other colleagues, then you might run into things like, oh, I wish I could share this code more easily, or have things like version control where I can see what changed. And these are things that both dbt and SQLMesh enable. So they enable version control. They also enable things like splitting up large queries into more manageable building blocks, and then even writing tests which are automatically checked for certain business rules where you can say, okay, this always needs to be valid. These are things that are harder to do with just plain SQL, and both dbt and SQLMesh enable in essence these software engineering principles to be used correctly instead of just using SQL directly.
All right. So in your own words, can you describe to the audience that probably never touched SQLMesh, what is it? What is the tool and what does it do?
Yeah. So it is a tool that allows you to define models which are SQL queries. And you can then have those SQL queries when you say to SQLMesh, hey, run my project. SQLMesh will ensure that the results of those models, those queries, are calculated in the right order. If they can depend on each other in a certain order, then it's also managing that correctly. And then it essentially puts the results of those queries for you in a data warehouse in the right order, also doing things like tests to ensure that the checks that you defined are valid. That's also similar to DBT, but where SQLMesh differs from DBT and where the fundamental difference between SQLMesh and DBT is, because all the things I mentioned now are quite similar, it has two fundamental different ways of dealing with data and with SQL. So on the one hand, you have this concept of what's called semantic understanding, which is that unlike DBT, SQLMesh will actually try to understand what your query is doing. It will parse the SQL query to try to understand exactly what it's doing. And then secondly, basically the semantic understanding allows it to do several cool things, which we can dive into deeper. But before I want to go too far into that, the other difference is that it has this concept of virtual environments, which is that unlike DBT, where DBT just you run the queries directly where the result needs to end up, there is this sort of virtual layer in between where the data is actually written in a schema that's managed by SQLMesh. It does some internal magic and state, keeps some track of state of what has already been run and whatnot. And then there's this virtual layers, which consists entirely of views, which then give you views on the right state of the right models, which are both two complicated things, but they allow several cool things to be done with the data, which is not directly possible with DBT. So it's to summarize, somewhat more advanced than DBT and slightly more complex, but there are some things that are enabled by this extra complexity.
All right. So maybe let's zoom into the first concept you mentioned of semantic understanding, and please correct me if I'm wrong, but how I see it in DBT, it's basically SQL plus a bunch of cookie cutter templates, right? So you write SQL with some template code in there, template variables, and then there's an engine that fills in those variables for you based on the environment you're in and whatnot. But you could write anything there. It doesn't have to be even valid SQL. It's just DBT is completely agnostic to what you write there, right?
Yeah.
And you say that's not true for SQLMesh. SQLMesh tries to build semantic understanding of your SQL query. Okay, why do I care about that? What is it?
Yeah, so the explanation you gave is indeed exactly how it works. I teach for Dataminded also DBT to, both clients and also internally. Like we have this summer school, winter school. I've given several courses of DBT. And this is really one of the struggling points for many people, which is sort of unexpected. The fact that it's really indeed just doing some templating, which is just string replacements of the query. It's just when you use a variable, it just pastes the result there. It does string replace. It doesn't try to understand what your query is doing at all. And then at the end of all the templating, you have some text, which is a SQL query, and then it gives it to the data warehouse. And then the data warehouse will try to, it will need to try to run the query. Maybe it gives some error. Maybe it actually ran successfully. But DBT does not know, or even also it doesn't really understand very much what the engine, the query engine gave as a result. If it gives an error on line this column that might not correspond to your actual code line numbers.
It's hard to debug sometimes.
Yes, these are several issues that people that are new to DBT really, it takes a mindset of this does not really intuitively make all that much sense. So that is in contrast to SQLMesh, where indeed it does try to parse your code as a query. So when it's tries to it sees your code, it expects there to be a valid SQL query with potentially some extra things like variables or macro function calls and things like that. And it also understands those. And then at the end, it does have a model, a structural model of what this SQL query represents and how all of the columns are related to other columns and how the structure of what it's actually doing. It will also, for example, then complain even before you send it to the data warehouse that maybe your query is not even valid. And it will be able to give you much more direct feedback when something's wrong. And there are like other things that really can be done with that semantic understanding of the fact that it, for example, just one example, since it knows which columns depend on which other columns, it can also visualize that for you. It can give you what's called column level lineage, where it shows you, okay, this column depends on this column and that depends on that column, which is much harder or almost impossible to do with DBT itself, or at least to do it correctly. So that's one of the advantages of doing the semantic understanding that SQLMesh is doing.
But then help me understand this. Like that's semantic understanding. Does that depend on the actual data that you write it against? Does it need to read the database first or the data warehouse and understand, okay, these are the source tables that come in, and there's a column cust ID and there's a column customer name and whatever? Or is it completely independent of the data warehouse that you run it against? It does need to know the dialect of the engine or the query engine or the data warehouse that you're trying to run against. So you need to configure ahead of time, okay, this query, it's, for example, Postgres or it's Trino syntax. So it does need to know which kind of SQL dialect your query is written in. But then, okay, it builds this mental model of what it's doing. So it knows, okay, it's combining these two columns and then aggregating on this third column. So it does understand that. And the mental model that it has of this query allows it to do things like also translating that query from one dialect to another SQL dialect. And that's by itself something that might be useful maybe in a migration. But there is this one particular thing where SQLMesh uses this, which is very cool, but a little bit of a dangerous feature. When you define tests to be run on a SQL model, specifically unit tests, which are tests where you define, okay, given these inputs, if you run this model, I expect these outputs. In DBT, you can also do this, but then it needs to actually send that data to the data warehouse. The data warehouse does the processing, then it looks at the results, does the result match? Okay, all of that happens by DBT does not do any of the processing there. That's all happening on the data warehouse. But in SQLMesh, it can translate your model to a different SQL dialect, such as DuckDB, which it can then actually run locally on your own machine. It can. DuckDB is a typical example of that, of a query engine that can run locally on your own development machine, on your own laptop, and then it can run all of your unit tests without even sending anything to a data warehouse. So none of your like test data or does even need to be sent to the data warehouse. You don't need to deal with all that complexity. It can then also be run as part of a version control CI/CD pipeline, and there are many advantages of that being possible. But I did mention, and I still kind of also like think that it's a dangerous feature as well. The fact that it translates your SQL query to a different dialect, that translation is not necessarily always perfect. There are some subtle differences between the different query engines, some subtle differences between the dialects of SQL. And if your translation is not perfect, you might have tests that say, yeah, all my tests are successful. But when you try to run it on the actual data warehouse, maybe your tests are not successful, or maybe your logic is doing something slightly different from what you expected. Yeah, exactly. And maybe we'll dive into that later when we come back to tests, but that's an interesting thought. Okay, so it has a semantic understanding. That's one difference from DBT, and it has the notion of what you called virtual data environments.
Yes.
Is that like a Python virtual environment? What should I imagine when you say a virtual data environment?
At a very high level, you can indeed compare it to Python virtual environments. What it means is that in DBT, so again contrasting it to DBT, where in DBT, if you define a model, which is a SQL query, DBT just runs and puts the result where you want it, like where you have it configured. Okay, put it on my data warehouse in that place, in that schema with that table name. Yeah. But SQLMesh will actually not do that directly. It will have its own schema where all the data, all the tables are actually written. So when it does calculations and when it does transformations, it always writes data to those internal tables. And then what is called the virtual data environment, that's the place where you expect your data to end up. It will not contain any data. It will not, or tables. It will contain views, which are sort of pointers to those data tables. So it might just be a select star from the data table. And that by itself, okay, that's not useful unless you do something with it. But there are several things that they are doing with that concept, which are very useful. And one particular one, which I find very useful, is this concept of like, well, instead of doing write, audit, publish, you can do instead of doing write, publish, audit, you can do write, audit, publish. So you can first, in this internal schema that SQLMesh is managing, write all your data, then do all of your tests. You did the writing, now you do the auditing, and only at the very end, when you are sure that all of your tests show that everything is as you expect, only at the end, then you can say, okay, now update all of my views to point to the newest version of the data. So the newest tables, and you can do that only after like all of the tests are successful.
Yeah. Well, I guess you could build that same logic manually in DBT, where you run your DBT models, then you run some tests, and only if those tests succeed, then you run another DBT model, which basically copies your data or creates a view or whatever.
Yes.
But this is the default way of doing things in SQLMesh.
It's indeed the default way of doing things. And yeah, another fundamental like difference there between what DBT and what SQLMesh are doing in this way. If you build this yourself in DBT, it's possible, especially if your data warehouse supports things like a schema swap, like in Snowflake. There are some things that are possible there, which like at some clients we even have seen it, and it can get to 90% of the way there. But what is SQLMesh also maintains is a state of what has been executed, what are my internal tables actually referring to, and when did I run which models last. And so yeah, the fact that it knows for each of those internal tables what it has updated and like what it has run and what's the state of everything, means that it, for example, if you are sure after your test that everything is successful, you can say, okay, now update my data. But then maybe later at night you wake up because there's an alert that's, okay, everything's apparently wrong, your test didn't catch it. In SQLDBT, the only thing you can do is now, okay, maybe we want to go back to the version that we had yesterday. We changed some code. That's quite hard in DBT. You might have to check out the older version of your code, rerun everything, or that's just a nightmare. It's not possible. But there in SQLMesh, since it still like has all the data that it just ran, but it also keeps the older versions of this data around for a while, you can actually just do a rollback by updating those views to say, okay, now point to the version I had yesterday, and that's it. You just instantly, or like very quickly, because updating those views takes very little time, update the data, and then, okay, we'll figure out what went wrong tomorrow. We just have a version of the data which we know is okay. It's maybe a day old, but at least it's not wrong.
Got it.
So that those rollbacks is a feature that's possible by SQLMesh, but that's not, unless you spend a lot of engineering effort rebuilding this concept, it's not possible in dbt.
Yeah. So if I can summarize what you said, those two features of the semantic understanding and the virtual data environments, it means that it introduces more data best practices out of the box, right?
Yes.
It's easier for you to do tests without affecting production. You become aware of what you're doing. It's you will get errors reported to you sooner, not when you run it. So that's the semantic understanding. And then the virtual data environment is you basically can run in a safe space, if you will, and then only when you're happy with the results, you publish it, and it's as easy to unpublish the results.
Yeah.
And all of these things, as you said, like you can 90% build it yourself in dbt, depending on the features of the underlying data warehouse. But here it comes out of the box.
Yes, indeed. So that's a nice summary. Another thing that's also possible with this is also because this internally managed schema is sort of independent of your environment. Like you have a production environment and a dev and a test and whatever staging environment, and maybe even some personal development environments. If you would have that in dbt, those would be separate schemas with also separate versions of the data, which like copying those would be very expensive. In SQLMesh, you can just create another virtual environment, which are also just views on the same production tables so you can just say, okay, I want to do an experiment. Let's copy the production virtual environment, make it a new virtual environment, call it dev Michiel, because I want to personally do some experiments. That copy is super cheap. You create some views, and then maybe you update like 2 models and do some tests on it, and then you are sure that everything after your tests is running successfully on the new version of the data, where only like the things you changed are actually need to be calculated. So it's much cheaper to run it in this way. There's also significantly lower costs on the data warehouse. That by itself is already useful, but then the next step, after you have published or have tested your data, you want to actually make the production environment reflect your changes. Then you can say to SQLMesh, okay, now update the production environment to be the same as my development environment. Also, that is instantly possible just by creating the pointer swap to make the production environment the same as your personal development environment. So these are the things that are enabled by this virtual data environment concept.
You know what it reminds me of? I don't know if you ever had the privilege and luck to work with a version control system called SVN. Before there was Git?
A little bit at university.
Yeah, so that was back in the day. Now I'm dating myself, but there was a time there was no Git. So you had, and then in Subversion or SVN, if you wanted to have a new branch, you would have to create that branch, but it meant a physical copy of all the files. And just creating a branch, it would take ages to get. And then okay, yeah, now I have a branch, and now I need to merge it again, and it was super slow to. So in essence, you had like 3 branches or something, because it was so hard to create multiple branches. While in Git, the first time I created a branch in Git, I thought like I mistyped it, because you do like git checkout B, this branch is like done. It's like, no. No, I didn't just create a new branch. It's like, but it's because, and I don't know the exact details behind the scenes, but it's also a virtual copy, if you will, of another branch, and it only tracks the changes. And then when you push the changes back, it only pushes the changes back, right? So that is a small nuance that, at least back then for me, was insignificant, but it speeds up development and experimentation a lot. It's so easy in Git to create a new branch, try stuff out. Okay, delete the branch, new branch, bam, 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 merge the branch back. Your developer speed goes up, basically. Yes. And I guess something similar in SQLMesh.
I like the analogy a lot, and I think it's very applicable. You could indeed compare like branches in Git, which are indeed pointers to a certain commit. Like a branch is nothing more under the hood than a pointer to this commit is this branch. And it's also as cheap to update as like indeed virtual environments are in SQLMesh. So it's a super cheap thing to like basically create a new virtual data environment in SQLMesh. Is sort of similar to creating a new branch in Git, where just it's some pointers and some internal state, but that's very, very easy to. There's no actual data calculations happening, and that's actually a very good analogy.
But then we do know the history of version control, right? Like Git replaced all other version control systems out there. So why is SQLMesh not more popular?
That's a good question. I think by like the primary argument, I think, is that DBT was there first, and they had this good idea of like, let's use like SQL as code, and like let's have these things of models representing what you want to run, where models can refer to each other. So it allows some good software engineering principles, like not repeating yourself, and many of the like simple things that are hard to do with just pure SQL are possible with DBT. So using DBT gets you like 80-90% of the way there. And SQLMesh is just some nice features on top. Like these virtual data environments, it took me a while to explain it. Like also the semantic understanding, it's sort of a more advanced concept, which if you are familiar with SQLMesh and if you are familiar with DBT, I think it's sort of a better way of dealing with the data, but it's a nice to have. It's not a must have. I think it's cool, and I think by being sort of a bit better in that sense, I think it will gain traction. I think we will see it grow, but DBT is just also good enough for most people if you just have it can do most of what you want.
Yeah, that is true, because this is not a let's bash on DBT podcast. I am a big fan of DBT.
Yes.
When it came out, it was like an eye-opening moment for me. Like, oh wow, this is like the best thing to happen to SQL since the invention of SQL. I don't know. So let's see. Maybe the data world is not mature enough yet to have all these complex things to embrace things like semantic understanding and virtual data environments. But what is not there today can come tomorrow, right? So
yes.
Before the podcast, you also shared with me that one thing that stands out for you in SQLMesh is working with the SQLMesh community.
Ah, yes.
Like what is that about?
So some background on why I said that is well, in Dataminded, I was part or actually the lead of what was called the analytics chapter, where we did some research and development on new and upcoming technologies. And one of those was on our radar, which was a SQLMesh. We did some experiments with that, and we also built some internal pipeline using SQLMesh. And as part of those experiments, we when you had questions, there's this community in SQLMesh, which is a Slack channel. And there, when I posted questions, I very quickly got answers, not just by any other people, but actually by the developers of SQLMesh. So it's Tobiko Data, that's the company behind it. I was just talking to the people that were developing it. So this was a very interesting experience, and shout outs to the creators of SQLMesh, that they were so helpful to people that were trying to use their tool, and was a very pleasant experience working with SQLMesh and their developers.
Yeah, and I guess today that's just not possible in DBT. There's so many people using DBT that, I mean, if the core developers of DBT would answer all the questions of the community, like that would be there. They have people doing full-time job as community management, right? And then it's not.
Yes,
okay.
That's true. Indeed, like I've never talked with the developers of DBT, but DBT is indeed so big that if you have an issue and you Google that issue, there's likely somebody else that also had that issue. So it's a much larger world in that sense.
Yeah. And so SQLMesh, like DBT, is open source. As I understand, they're not in version 1.0 yet, but they are releasing like crazy, right? So what is it about?
So they have a very crazy release schedule where they are releasing new versions multiple times a week sometimes, or even in some cases multiple times a day. So basically they have a rolling release every time they have some minor change. Maybe one bug is fixed. Okay, it's a new release. So they have a very active release schedule. They are really developing like crazy still. It's going very fast. They are improving very quickly. And now they are they're not in version 1 yet, but they are at version 0.170 or something like that. Wow. So it's they have done a lot of releases, but they are not at version 1.0 0.0 yet.
By the time this podcast is recorded, they might be at version 0.180 or something. You know?
Yeah, probably. This will date the time of our podcast recording.
Almost to the hour.
Yeah.
Okay. So we talked about DBT, about SQLMesh, but they are not the only ones in this landscape, right? So what are some of the other competitors?
So some of the other competitors in, the space of working with SQL as a software engineer, if I could summarize it in one sentence like that, there's two others that stand out. It's basically SDF, and there's also Dataform. Dataform is the oldest of those. It's basically also similar to DBT, but it only works with BigQuery, so it's only on GCP. It was acquired by Google, and now I have less experience with them. I haven't looked at them all that much, because if you are not working on GCP, or if you're not working on BigQuery, then I don't think it's possible to even use Dataform without using BigQuery.
It used to be the case that before they were bought, they were like data warehouse agnostic, but then they got bought by Google. So I'm not surprised that they now only support BigQuery.
Maybe they still do support other things. I like I said, I don't have that much experience with it, but it's primarily designed for BigQuery. So that's Dataform. The other big competitor in this space is SDF, and SDF stands for Semantic Data Fabric, and that semantic there is also referring to the fact that, just like SQLMesh, SDF also does this parsing, this semantic understanding of the SQL model. So it also has that similar aspect. You could kind of say, in some sense, it's like a too short summary, but you could say that SDF is sort of SQLMesh written in Rust. It's basically written in the programming language Rust, and as a consequence of that, it's a very fast tool. It's easy to easy to install, and it's very snappy, which DBT is not necessarily. It can be quite a slow CLI to use. And also, it does this parsing of all the SQL models in this Rust engine. So basically that allows them to also parse all of your SQL queries very quickly. And why is SDF relevant in this case? Well, they were actually acquired by DBT in January, so only 3 months ago. They were acquired by DBT, and that might bring to DBT some of these things that we talked about. But it remains to be seen. It's only a very recent acquisition. What features of SDF will actually be brought to DBT? In some announcement blog posts, they talked that not all of the SDF source code, which was not or still is not public, it will not all be open sourced, but they will try to bring some aspects of this SDF to DBT. But what that actually means, they didn't clarify in that announcement blog post.
And then is it DBT Core or DBT Cloud, right?
Yeah, they also did not clarify that. I think it's a good question whether or not they will release this this semantic understanding, the fact that the parsing is written in Rust, the fact that you get this. I think, doing some wild prediction here, but this might be completely wrong, I think some parts internally of DBT might use that parser that SDF has to maybe do some faster processing, make the CLI commands maybe more snappy, to actually get all the way from all of the features that SDF has, put them all into DBT. It's gonna be I think it's gonna be a long, drawn out story, because they also need to think about backwards compatibility. It's not just easy. You can't just replace everything and now expect everything to still be the same while maintaining backwards compatibility. It's gonna probably take a long time to see the full improvements of this, but that's remains to be seen in the future what's going to happen there.
Yeah. The cynic in me thinks that it might also just be an acquisition to kill the competition.
Maybe, I think so. But if you look at things like website visits, which is a very remote proxy for how much it is used, it is like DBT is like literally almost 100 times bigger than these competitors, including SQLMesh, or maybe not 100, but on that order of magnitude, right? It's much larger than all the other competitors. It is really like a very large difference.
Squash them when they're small.
Yeah, when they're small. That's true. That's true. Maybe it's a bit of both.
I don't know. Well, let's see. I have no information here, so I'm purely speculating. But coming back to that semantic understanding, what is the underlying technology that makes that work?
So the SQLMesh is based on a Python library by the same developers. Also, to Pico Data, it's called SQLglot, and that SQLglot library is the thing that can, in Python code, do the parsing of SQL queries, just arbitrary SQL queries. That's also then what's being used by SQLMesh, but that allows just doing things like taking SQL from one dialect and translating it into another SQL dialect, and that is useful besides just like SQL. If you don't use SQLMesh, we found that library very useful. So SQLglot is we've used it at clients also like several times. When one source system was had some views in one in one SQL dialect, and we wanted to run it on a different data warehouse, then you can just use that technology, and it works quite well. It then also has all of those features of the same parsing engine, the same translating engine, the same structural understanding is then also part of that library.
Okay, and then if you dive into the testing part, which uses that semantic understanding, can you walk a bit through with me how testing works in SQLMesh?
Yes, so I already briefly explained it, but I think it's the unit testing in SQLMesh that I think is still a very, very cool idea where there's the concept of unit testing and data testing, where data testing is doing assertions about, okay, I expect all the values in my table to be this, or I expect this many rows, or some basically assertions about the data in your tables. That's similar in DBT and SQLMesh. It's very easy to define such tests. You can just, in a few lines of typically YAML code or potentially writing a query, check the things you want to check. And in that sense, there's not a big difference between SQLMesh and DBT. But there is this, the unit test there, as I mentioned, that really is a difference where, like in SQLMesh, the fact that you can translate your queries to a different dialect using this SQLglot engine to translate it and then run it on a different query engine, that is a very interesting concept. Like, it is a bit dangerous, but it is the other thing that's possible by this semantic understanding of the of the query engine and of the SQLglot engine there. And another thing I wanted to mention in relation to the testing is this concept of data contracts. In both DBT and also in SQLMesh, you have this concept where, okay, I have defined typically in YAML some structure that I expect my table to have these columns with these data types, and then you can say, I don't this should always be true, or don't even run the model. This is possible in DBT. By DBT asks essentially the data warehouse of what would be the output of this model, to then check, okay, is it the output as I expected it? And then it will only run the query if it would actually produce the structure that you expected it. Now, that's also possible in SQLMesh, but there it can actually go a step further. By structurally doing the parsing of, okay, what is this query doing? It can also understand, okay, this query, the change that you are trying to do here, maybe it changes the column layout. And then it can tell you there's this command called SQLMesh plan, which is similar to like Terraform plan, which is before you actually run any calculations, tell me what you're going to do and tell me what is going to be a breaking change. And so there it can tell you, okay, here you are changing this column, and here you are renaming it to something else, or here you are removing a column. So these are like, it can detect that this will be a breaking change. And so it can do that on the level of schema, where it detects that your columns will be different by data type, by name. And it can also just tell you, okay, this change that you're trying to do, it will be a breaking change by its logic. So for example, you do some filtering, which we weren't doing before, or like that can also be detected as a breaking change. Even if the column layout is different, it will tell you, hey, this is also a breaking change.
But then I'm curious, let's say I apply a filter where country is Belgium or France, whatever, and I didn't apply that filter before. How does it know, like, what does it consider to be a break, or when is it breaking, right? Because applying a filter doesn't break anything. I update my logic, or what am I missing there?
I'm not an expert on this sense, so it's kind of hard to fully say like with certainty, but essentially what is considered a breaking change is if you change something that could be detected by the downstream models that depend on the model that you are changing. So if you are indeed, like you say, filtering and adding a filter, okay, I only want the rows where the country is equal to Belgium, that affects models downstream or it could theoretically affect models downstream that are depending on the data that's the output of your own model. And it can show you, hey, here you are doing this, what's potentially a breaking change, right? But then secondly, it also, can do, when you do SQLMesh plan, it will know, okay, you did a breaking change to this model. If I want to rerun to be up to date with the current state, I need to rerun these downstream models. Even if, okay, maybe structurally, like it has a structural semantic understanding, maybe it doesn't fully understand all the changes that you're doing. Maybe it's rerunning something that theoretically shouldn't have been rerun. So maybe it's a bit too cautious on that sense, but it will, or should at least detect the changes that you are applying, which are considered breaking changes by the fact that some downstream consumer could theoretically notice that something changed and needs to be updated to reflect it.
So since you change your logic, downstream consumers might be impacted. Well, depends on which table you output to, of course, and then there is a command in SQLMesh that says, okay, update all my descendants or whatever when I update.
Indeed, if you just change your code and then do this command, SQLMesh plan, it will show you, okay, based on your change, I will need to change the model that you just modified, but then also potentially these and these and these downstream models that depend on it. So it will tell you before you actually do the calculation what it is intending to update.
Yeah, and so coming back to the testing, you already mentioned two kinds of tests, like unit tests and data tests. And data contracts and data tests are, let's say, very related concepts, because with a data contract, you run certain data tests, and if they're invalid, you say, well, you're breaking the contract, and whatever happens then. And data tests, in my experience, is something that most people understand. They understand you need to check if a field is not expected to be null, you can validate that it's not null, right? Yeah. Because what most people don't know when they move into analytical worlds is that in operational databases, it's very easy to define constraints on a database. So you can just say this field cannot be null. This has to be a unique key, whatever, so there cannot be duplicates. But in most analytical databases, those features are not there for performance reasons, right? So you even if you can define constraints, very often they're not enforced. And also the kind of data tests you want to do are typical more higher level, right? So if you say, I populate country and I populate continent, you cannot say country Belgium and then continent America, something like that. It has to be like a referential integrity, if you will. Well, it's not exactly that, but typically there's more business logic that you want to check in those data tests. So and you already mentioned, you can do that in both. What people often underestimate is logic tests or unit tests, right? And there you said unit tests are more easily possible in SQLMesh. I remember about a year ago, something when we were doing DBT, you could also define unit tests in DBT, but back then we used some kind of external third-party library. I've heard now this is built within DBT to do unit tests in DBT, or how does that work?
So at DBT, indeed, it used to already be possible with this external package called DBT unit testing. It essentially, it's a very well-written package working within the constraints of DBT packages. It was able to provide unit testing, and it's pretty clever how it was implemented, but by not being a part of the DBT core functionality, it was somewhat restrained, and where you see that was not fully always intuitive is some in things like the error messages. If you had some syntax wrong with it took a while to write a valid unit test. So that's one thing that's now improved by the fact that in DBT version 1.8, I think, they added the core concept of a DBT unit test, which indeed there you can in YAML define, okay, this model I expect given these inputs should give these outputs. That YAML is just another way of defining a unit test. It's mostly, it has the same capabilities, but it is slightly more intuitive to use and gives more nicer error messages. A small detail which was a big gotcha in the package is you had to, if you were referring to other models, you have to replace the ref call by this DBT unit testing .ref, and that was that's the big gotcha that was part of that was just necessary by the fact that it was an external package. They couldn't override the built-in ref function, so they had to provide their own. And so that package is still available. You can still use it. It doesn't mean you have to migrate to the new version, but okay, the built-in core version does have slightly nicer error messages, and you don't have to replace your ref function with this DBT unit testing.ref. But structurally, they are kind of similar. And in that sense, the SQLMesh unit testing is also somewhat similar. They have this nice feature. Okay, they can run it locally. There is one also cool thing about SQLMesh, which I haven't mentioned yet, but this is, they have a command. I don't know the name of it, but it was something called SQLMesh generate unit test, where it looks at your input data and output data, and then it just generates a unit test based on that. So it just fills in, it says okay, take 5 input rows and 5 output rows and generate a unit test based on the data I currently have in my data warehouse. Can generate the code you need to define that unit test. You probably will still need to go in and replace sensitive data with fake data, stuff like that, or maybe tweak some of these input values a little bit to do what you want. But you already get it's going to be correctly formatted. You're going to have the correct syntax and stuff like that. So that's also a cool, nice to have feature. I think it's pretty interesting that they have.
Yeah, that's, to be honest, that's exciting and scary at the same time. It's exciting because it promotes the use of unit tests, lowers the barrier of entry to add a unit test. And I think, by the way, that if there's, maybe I'm getting older, but if there's one thing that I find engineers today don't do enough, it's writing unit tests. Even within Dataminded, I had those discussions. I just 2 days ago, I looked at someone's code base, and there was a long list of Python logic and SQL logic, and there was zero unit tests.
Yeah,
it's no, that's not something we do in this project. And I know I'm not a developer for a while now, so I didn't want to jump in and start micromanaging that project. But unit tests have saved me so many times in the past, where just the act, and that's why it scares me, the act of writing down the unit test, it's a bit behavior-driven development, right? So you say, given I give this input, when you run this function, then I expect this outcome. It makes me think about the logic that I should write, right? So in software engineering, in BDD, you have the notion of, or TDD, test-driven development, you first write the test and only then you write the logic, right? And for some reason, the data world is, let's all be honest, it's running a bit behind,
It's true. I think it depends slightly on the technology used. in DBT and SQLMesh also like it takes quite a bit of effort to get it like to write a unit test, and that makes it hard. Like the barrier to actually writing it takes more time. Whereas I heard from like feedback from a colleague working with Spark, where it's just Python, where you just have PyTest available, and there actually unit tests are written more frequently. And actually, I heard sort of the argument there that maybe in some colleagues they were using too many unit tests and not enough like data tests. So it depends, I think, a lot on the tool you use and how easy it is.
Well, writing unit tests for the sake of code coverage is bullshit, right? So you should write unit tests to test your logic. If everything you do is join two tables, well, your database can do a join. There's no point in testing if a join works, right? So it's always when you do more on the business level, try to explain what kind of behavior you expect from your code, not like will the technical join work. And there I do agree, unit tests is only covering part of it. Things break in production because your code is shitty or the data is shitty, right? Yeah, it's true. So you need to test both of them, right? And data changes all the time, code changes all the time, your schema change all the time. So you need to test all these things, right? So it's difficult.
I agree. Like on both fronts, testing is really not like it's not being done enough. Like it's really like there's a great story that I heard a while ago, which I think really underlines this fact, which is back when there was COVID. There were vaccines that were being developed, and then there had to be some sort of priority list of, okay, who do we send these vaccines to? And top of the priority list there was a person somewhere in Britain who really was the top of the list, apparently by being morbidly obese. But okay, there was in this article also a picture of that person. He was not that obese. And the reason for why he was put at the top of the priority list is, well, when his doctor, his physician, entered his height, he entered, instead of 6 feet and 2 inches, he entered 6.2 centimeters, which gave him a BMI of 30,000. Which, if then you look at, okay, classification of BMI, that is morbidly obese, so he needs to be one of the first to get the vaccine. Now, what that really undermines in terms of data testing is nowhere in that chain, from the doctor entering this height of 6.2 centimeters for a person in their 30s, to the data being sent to the servers, to some API, to it being stored in some operational database, to it being sent to some analytical database, to some actual logic determining maybe several pipelines deep of who do we actually send the invite to actually the person receiving the invite in their mail. Nowhere in that entire chain was it ever checked like, hey, a BMI of 30,000. Does that make sense? So, I mean, in the world of data, I think there's just not enough data testing happening.
No, indeed. There's way more bad quality data than there's good quality tests, right?
Yes.
But coming back to SQLMesh, apparently it does have DBT integration, right? So does that mean you can easily migrate from DBT to SQLMesh?
There is indeed this way you can actually take a DBT project and use SQLMesh to run it. And there is this integration. There are a few things you need to define, and theoretically that should allow for a very easy migration. But I read a blog post about this by somebody who really had a significant amount of work in building DBT pipelines and translating that to SQLMesh, and they share their experience where it didn't turn out to be so easy. And the main reason for that was, well, the virtual data environments. They actually, the fact that you in SQLMesh expect everything to be like internally managed, and then the output should always be like these views. That means that if you have a already existing project, then you can't just easily delete all your data and then try recreate those views and basically migrate slowly. Have some models which are DBT models and some models which are SQLMesh models. So it wasn't there are some gotchas there, so it's not super easy, but it does have this DBT integration, which I mean, gets you already part of the way there, but there are some gotchas there, which doesn't make it a super snappy take this DBT code and just run it in SQLMesh, because they are somewhat fundamentally different, and in that sense, the virtual data environments is not perfectly it's just a bit of a leaky abstraction in that sense.
If you look at dbt Cloud, not dbt Core, but dbt Cloud, they also have something called a semantic layer, and they also have something called column level lineage.
Mm-hmm.
Is that the same as the features in SQLMesh, or is it different?
No, indeed, they are somewhat different. The semantic layer is essentially it's a dbt Cloud feature where they define semantic models, it's called, which you would think, okay, that's maybe similar to a model which they have semantic understanding of, and there is some overlap there, but what it means is these semantic models are things you don't define in SQL, but you define them in YAML with predefined structure, and dbt does understand the meaning of that. These semantic models. It's not designed for arbitrary SQL query logic. It doesn't do all the things that you can possibly do in SQL with window functions and things like that. But it's sort of designed for time series data, dimensional data, where you can drill down, which you can then easily visualize with. They have some integrations with metric flow. I think maybe saying this wrong, but metric flow, I think, is
metric flow. Okay,
maybe sure. I'm not 100% sure about this, but so basically they have some integrations where they I don't have personal experience with that, but those semantic models, you can define them in YAML, and then there are some integrations with that. Also, they do indeed have column level lineage. The difference between the SQLMesh kind of semantic understanding of a model and the dbt version of column level lineage is in dbt. It really only parses the compiled SQL, which means, okay, after all of these text replacements by your macro, then at the end, the query that you send to the warehouse, that's being checked to check what is the SQL logic that translates one column to another, and there, okay, it's if your query already ran successfully, but the parser didn't understand it, it's also not perfect. It did some experiments with this, and okay, it detected most things, but when we tried to use advanced things like BigQuery specific pivot functions and stuff like that, it sort of didn't always correctly give the full column level lineage.
Yeah, in general, my experience with column level lineage is that data leaders often want it, but the reality of implementing it becomes very complex, very fast, regardless of technology, right?
Especially if you want it to be accurate, and if you want to rely on it being accurate, that's a very, very, very tough challenge.
So this is the podcast is the Data Playbook, so we want to give playbooks to data leaders, right? So we went quite in depth in SQLMesh today. What are some arguments for or against using SQLMesh at a client?
So you already mentioned it, this is not, I didn't want to come here bashing on DBT. I think it still makes sense to use DBT, especially even at most enterprises, or maybe you should make a careful decision about SQLMesh versus DBT, not just SQLMesh is better, so let's always use SQLMesh. I think the fact that, the fact that you have this extra concept that takes some getting used to, that's maybe one situation where I might just go to the simpler DBT, these virtual data environments and stuff like that. If you also have to explain that to somebody who is maybe only used to writing queries in a user interface and is new to the world of software engineering and things like Docker and Git and compiling things and all of that, if you need to explain just all the core concepts of DBT, for such an environment, maybe DBT is the simpler tool to use. But if you have a more technical team of data engineers there, then and you are willing to accept that by the fact that it's a smaller community or a smaller product, less used, less battle tested, maybe you might maybe run into a bug, and you might maybe not be able to find 10 other people that also had that bug and find on Google like immediately the answer to your problem, but you're willing to take that risk, then I think SQLMesh really can be a great tool to use, and all these advantages that we just discussed in the past hour can really be make SVN to get that comparison.
And are you somewhat afraid of the fact that it's not V1.0 yet, so afraid of breaking changes?
I think that's not necessarily the thing I would be most concerned about. I don't think it's... it depends a bit. Indeed, if you have this thing that if you want to write it once and then it needs to remain stable without being touched for a long time, maybe things will need some more attention. Maybe I'm not sure about this. I like it is indeed a risk, the fact that it's a V0 a huge number. So yeah, it's indeed some risk. I think the slightly bigger risk is indeed the fact that it's like smaller. It's like less tested by large companies. It's still I mean, has a smaller backing of like the company behind it is smaller than DBT is. So those are things that would be like, if you use DBT, DBT is going to work. You're just not, there's no question really about that. Whereas with SQLMesh, maybe you might run into a bug that nobody ran into before. And
right. Cool. Well, super interesting thoughts and reflections on SQLMesh. To zoom out a bit before I let you go, it's a question asked to everyone who comes on the podcast. What is for you the biggest lesson you've learned in data in your career?
Yeah, and you were going to ask this question, and I had to think a bit. But ultimately, the biggest lesson I learned is to keep things simple. Like the reason is mostly, I've worked with several clients, but in one in particular, there was a somewhat larger feature where I made the mistake of really thinking everything ahead of time, like, oh, what if this happens? What if that happens? And maybe over-engineering it a bit too much at the start, and instead of really putting it out there, like, and getting people to use it, and then iterating on feedback. That was for me like the thing I should have done more at the start. And I think this ties back into the story of SQLMesh versus DBT. It's like, why is DBT so much larger than SQLMesh? They were there first. If they at the start didn't release DBT because they were saying like, maybe our data environments should actually be virtual data environments, and we just do text replacements instead of full like semantic understanding. Let's not release anything yet. That would be a mistake for DBT to have made. So I think keeping it simple and just building simple things and then iterating on them. That's for me the biggest lesson learned that I
love it, because I always promote the fact of iteration, learning, try again. But there's indeed the engineering, all of us, we don't want to fail, right? So we want to make it perfect. But sometimes shipping on time is also a feature, right? And we sometimes miss that feature.
Yes.
Yeah. All right, Michiel, it was a very interesting discussion. Thank you very much for coming on this podcast.
It was a pleasure. I enjoyed it.
Cool. Thank you.
Okay, thank you.